On March 15th, 1955, a man named Michel Bessot died in Geneva. He was 82 years old. He had been Albert Einstein's closest friend for over half a century. They met as students, argued about physics over coffee, exchanged letters for decades. Bessot was the only person Einstein thanked by name in his 1905 paper on special relativity. The only one. And 6 days after Bessot died, Einstein sat down and wrote a letter to the Bessot family that contains one of the most disturbing sentences in the history of science. He offered his condolences. He acknowledged the loss. And then he wrote this: "Now he has departed from this strange world a little ahead of me. That means nothing. People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion. That means nothing." 3 words that should stop you cold. Einstein's best friend just died. The man he had known for over 50 years, the man he discussed his most important ideas with before anyone else, the man who sat with him in the patent office in Bern in 1905 while he was rewriting the laws of the universe. And Einstein's response to his death is 3 words. That means nothing. He is not being callous. He is not being cold. He is being precise. He is saying exactly what he means, in the way that physicists say things. And what he means is that Bessot's death is not what the family thinks it is. It is not an ending. It is not a disappearance. It is not a transition from existence to non-existence. It is a feature of a geometry, a coordinate in a structure. And the structure does not care about coordinates. It contains all of them, equally, permanently. Think about what Einstein is actually saying here. His best friend just died, and Einstein is telling the family that this event, the death, does not mean what they think it means. He is not being poetic. He is not offering spiritual comfort. He is stating what he believes is a physical fact. The past is not gone. The present is not special. The future already exists. Bessot's life, every moment of it, is still there, still real, still happening at its location in the structure of the universe. Death is not an ending. It is a coordinate. Einstein died 4 weeks later, on April 18th, 1955. And if he was right about what he wrote in that letter, then he is still writing it. You were taught that the past vanishes, that moments once lived are gone, that right now is real in a way that yesterday is not. That time flows like a river, carrying you from birth to death, and everything behind you dissolves. This is wrong. Not metaphorically, not philosophically, physically. The most experimentally confirmed theory in the history of science, special relativity, does not merely suggest that the past still exists. It requires it. The math requires it. The logic requires it. And the experiments you rely on every single day without knowing it, have confirmed it to a precision that would be laughable if it were not so disturbing. Here is where it starts. 2 people are walking down a street, ordinary people, ordinary speed. One is walking toward the Andromeda galaxy. The other is walking away from it. Their relative velocity is trivial, a few feet per second. And yet, because of what Einstein discovered in 1905, their planes of simultaneity, their definitions of now, are tilted differently. Over short distances, this tilt is meaningless, but Andromeda is 2.5 million light years away. And over that distance, the tiny tilt produced by ordinary walking speed accumulates into a disagreement of more than a week. For one of those people, an alien fleet on Andromeda has already launched. For the other, the decision to launch has not yet been made. Both of them are right. Neither observer is privileged. Neither perspective is more valid than the other. Roger Penrose described this thought experiment in The Emperor's New Mind in 1989, and it has haunted physicists ever since, because the implication is inescapable. If one person's now includes the fleet already launched, and the other person's now includes the decision unmade, and both are equally valid descriptions of reality, then the only consistent conclusion is that all of those events, the launch, the decision, the moments before and after, already exist. They have to. If they do not, then you are forced to say that one observer's present is more real than the others, and relativity explicitly forbids that. The math is straightforward. The Lorentz transformation gives you a time shift of approximately velocity times distance divided by the speed of light squared. At walking speed, roughly 1.4 meters per second, over the distance to Andromeda, roughly 2.365 times 10 to the 22nd meters. The shift works out to about 4.3 days. That is, per person. If two people are walking in opposite directions, the combined relative velocity is about 2.8 meters per second, and the disagreement about now on Andromeda doubles to more than a week. 8.5 days, two people standing next to each other on a sidewalk, moving at the speed you walk to the grocery store, cannot agree about what is happening right now on Andromeda. And the disagreement is not about some obscure quantum effect. It is a direct, inescapable consequence of the most experimentally confirmed theory in the history of science. Penrose presented this thought experiment in 1989. It was not new. The underlying physics had been known since 1905. The formal logical argument had been published in 1966, but Penrose had a gift for making abstract physics viscerally disturbing, and the Andromeda paradox did exactly that. Because it took the relativity of simultaneity, which sounds like a technicality about clocks, and turned it into a statement about reality. A fleet has launched. A fleet has not launched. Both are true. Both are happening now. And if both are true, then now is not a thing. It is a perspective. And the events themselves exist regardless of whether you happen to be looking at them from a frame where they are past, present, or future. This is not a thought experiment about Andromeda. It is a thought experiment about you, about the moment you are in right now, and whether it is fundamentally different from the moment you were in 5 minutes ago. Physics says it is not. Physics says 5 minutes ago still exists at its coordinates in the same structure that contains this moment. And 5 minutes from now already exists there too. And here is the part that should genuinely unsettle you. Later, when physicists tried to write the master equation for the entire universe, combining quantum mechanics and general relativity into a single framework, time did not merely become relative or flexible. It vanished. The equation has no time variable at all. But that comes later. For now, stay with the letter. Stay with Einstein telling a grieving family that their loss means nothing because he is about to be proven right in ways that nobody in 1955 could have imagined. To understand why the past still exists, you need to understand what Einstein actually discovered about simultaneity. And to do that, you need to understand what he destroyed. Before 1905, time was simple. Newton's universe ran on a single universal clock. There was one now that stretched across all of space. If a star exploded 1 billion light years away, there was a fact of the matter about whether it was happening right now or already happened or has not happened yet. The present was a clean, flat plane cutting across the universe, and every observer agreed on it. This was not just a scientific assumption, it was a human one. It is what your brain assumes every moment of every day, that there is a now that is shared, that when you say right now, you are referring to something real and universal. Einstein's paper on the electrodynamics of moving bodies, received by the journal Annalen der Physik on June 30th, 1905, destroyed this. The critical insight is buried in the first 2 sections of the paper, and it is one of those cases where the most important scientific revolution in history is hidden in the driest possible language. Einstein asks a question that sounds almost childishly simple. How do you know that 2 events happening in different places are simultaneous? How do you actually verify that something happening over there is happening at the same time as something happening over here? You might think the answer is obvious. Look at them both at the same time, but that does not work because light takes time to travel. If a star explodes and you see it now, the explosion actually happened years ago, at a distance measured in light years. So you need a procedure. You send a light signal to a distant location, it bounces back, and you define the event at the distant location as simultaneous with the midpoint of the send and receive times. This seems perfectly reasonable, and it is, until you realize that 2 observers moving at different velocities, both following this exact same procedure, get different answers. The answer, Einstein realized, requires a procedure. You have to send a signal, a light signal, because nothing travels faster than light. And when you work through the procedure carefully, something terrible happens. 2 observers who are moving relative to each other will disagree about whether those distant events are simultaneous, not because one of them made a mistake, not because their clocks are broken, because simultaneity itself is not a feature of the universe. It is an artifact of your reference frame. It depends on how you are moving. This is not a subtle effect that only matters at near light speeds. The effect is always there. At everyday speeds, it is tiny, undetectable, without extraordinary instruments. But it is there, and over large distances, even tiny velocities produce enormous disagreements about now. That is exactly what the Andromeda paradox demonstrates. This is the relativity of simultaneity, and its implications are staggering, because if now depends on your velocity, then there is no universal now. And if there is no universal now, then you cannot say the past is gone and the future does not yet exist. Gone for whom? Not yet existing according to whose clock? An observer moving at a different velocity draws the line between past and future in a different place. Your future is someone else's present. Your present is someone else's past. And no one is wrong. The philosopher Wheeler-Putnam, in a 1967 paper called Time and Physical Geometry, put the conclusion with devastating clarity. If what is present is real, and no observer is privileged, and the reality of events is not observer-dependent, then all events, past, present and future are equally real. His verdict was a single sentence. At least he was wrong if relativity is right. He was talking about Aristotle's view that the future is open and unreal. Aristotle had been the default assumption of Western thought for 2,000 years. Einstein overturned it in 1905, and almost nobody noticed. But someone did notice. And his story is one of the great ironies in the history of science. In September of 1908, a mathematician stood before a room full of scientists in Cologne, Germany, and pronounced a death sentence on time. The room was the 80th Assembly of German natural scientists and physicians. The mathematician was Hermann Minkowski, and the first words of his lecture would become the most quoted sentence in the history of physics after Einstein's E equals mc squared. The views of space and time which I wish to lay before you have sprung from the soil of experimental physics, and therein lies their strength. They are radical. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Doomed to fade away into mere shadows. This is not a physicist hedging. This is not someone saying it might be useful to think of it this way. This is a declaration. Space alone is not real. Time alone is not real. Only the four-dimensional union, space-time, is real. And in that union, the distinction between past and future is no more fundamental than the distinction between left and right. It depends on how you are oriented. The irony is that Minkowski was Einstein's former math professor. At the Swiss Federal Polytechnic in Zurich, Minkowski had taught mathematics to the young Einstein and was distinctly unimpressed. He told his colleague Max Born, "It came as a tremendous surprise, for in his student days, Einstein had been a lazy dog. He never bothered about mathematics at all." In German, the phrase was fauler Hund, lazy dog. When Minkowski learned that this same lazy dog had produced the theory of special relativity, he reportedly said, "I really would not have believed him capable of it." And then Minkowski did something that the lazy dog had failed to do. He saw the geometry. Einstein had written down the physics, the equations, the predictions, the experimental consequences, but Einstein had not seen the deeper structure. Minkowski recognized that Einstein's special relativity was not just a set of equations relating space and time. It was a description of a four-dimensional geometric object. Space-time, a block, a structure in which every event that has ever happened and every event that will ever happen exists at a specific set of coordinates, just as every point in space exists, whether or not you happen to be standing there. Minkowski introduced the concepts that made the block universe mathematically precise. World points, which are events located at specific coordinates in four-dimensional space-time. World lines, which are the paths that objects trace through space-time, not through space, through space-time. The light cone structure, which defines the causal boundaries of what can influence what. And the space-time interval, the four-dimensional distance between events that all observers agree on, even when they disagree about space and time separately. Einstein initially dismissed all of this. He called it superfluous learnedness, unnecessary mathematical decoration on a theory that already worked perfectly well with algebra. This was a mistake, and Einstein later admitted it. By 1912, he wrote, "I have become imbued with great respect for mathematics, the subtler part of which I had in my simple-mindedness regarded as pure luxury until now. The lazy dog needed the professor's geometry after all. Without Minkowski's four-dimensional framework, general relativity would have been impossible. Think about what Minkowski's spacetime actually looks like, because this is where the full weight of the block universe becomes concrete. Imagine you could see in 4 dimensions. You would not see objects moving through space over time. You would see world lines, static, frozen trails stretching through the 4-dimensional block. A planet orbiting a star would not be a moving sphere. It would be a helix, a corkscrew-shaped wound around the world line of the star, extending from the beginning of the solar system to its end. A person would not be a body that ages and changes. A person would be a worm, a 4-dimensional worm stretching from birth to death, thicker in middle age, thinner at the extremes, every moment of their life existing simultaneously as a cross-section of the worm. You, right now, are a cross-section, one slice of a 4-dimensional object that extends backward to the moment of your birth and forward to the moment of your death. The slice feels like the present, but it is not special. It is just where you happen to be looking from. The rest of the worm, the child, the teenager, the old person, is all there, all equally real, all equally present in the structure. You just cannot see the other slices because your consciousness is embedded in this one. This is not metaphor. This is what Minkowski's mathematics describes, and every experiment since 1908 has confirmed it. But Minkowski never saw general relativity. He never saw the century of physics that flowed from his insight. On January 12, 1909, less than 4 months after delivering the lecture that dissolved time, Hermann Minkowski died of a ruptured appendix. He was 44 years old. Antibiotics did not yet exist. According to some accounts, his last words were, "What a pity that I have to die in the age of development of relativity." The man who declared that time is a shadow could not buy himself another year of it. And here is what makes this story worse. The mathematical framework Minkowski created did not just support the block universe as a possibility. It required it. In Minkowski's formulation, there is no way to select a preferred now slice through the 4-dimensional block. Every way of slicing space-time into space at a given time is equally valid. There is no objective present, and if there is no objective present, then the block simply sits there, complete, containing all events, and the experience of time flowing through it is something that happens inside the block, not to it. This was 1908. The implications were clear to anyone who thought them through, but almost nobody did. The physics community absorbed Minkowski's mathematics and ignored his metaphysics. They used the 4-dimensional framework as a calculational tool and pretended the block universe was just a manner of speaking, not a description of reality. This is a pattern you will see repeated throughout this story. The math says something uncomfortable. The physicists use the math, but refuse to say out loud what it means. It took almost 60 years for someone to write down the formal proof. In 1966, a Dutch physicist named C.W. Rietdijk published a paper in the journal Philosophy of Science titled "A Rigorous Proof of Determinism, Derived from the Special Theory of Relativity." 1 year later, independently, the American philosopher Hafele-Keating published his own version in the Journal of Philosophy. A third philosopher, Nicholas Maxwell, independently rediscovered the same argument in 1985. The fact that 3 people arrived at the same proof independently tells you something about how obvious the logic is once you actually follow it. The argument goes like this. Take two observers, call them A and B, who are in relative motion. According to special relativity, they disagree about which events are simultaneous. There exist events in A's future that are in B's present. If we accept that B's present is real, and we accept that no observer is privileged, then those events in A's future must also be real. Now introduce a third observer, C, moving at yet another velocity. Events in B's future may be in C's present. By the same reasoning, those events are real too. Extend this chain of transitivity across all possible observers and all possible velocities. And the conclusion is that all events at all times are equally real. The past exists. The future exists. The block universe is not optional. It is a logical consequence of two premises that every experiment in the last 120 years has confirmed. Putnam's verdict was brutal and precise. I conclude that the problem of the reality and the determinateness of future events is now solved. Moreover, it is solved by physics and not by philosophy. And then the sentence that landed like a verdict on 2,000 years of Western thought. At least he was wrong if relativity is right. He was talking about Aristotle's view that the future is open and unreal. Aristotle had been the default assumption of Western thought for over 2 millennia. Einstein overturned it in 1905. Putnam proved the overturn was logically inescapable in 1967, and almost nobody noticed. The most common objection comes from the philosopher Howard Stein, who argued in a 1968 paper titled On Einstein-Minkowski Spacetime that the concept of present should be understood as purely local, not global. In Stein's view, the only events that are definitively real for an observer are those in the observer's own past light cone, the set of all events that could have causally influenced the observer. This technically avoids the Rietdijk-Putnam conclusion, but at a devastating cost. It means there is no meaningful sense in which distant events are real now for you. Your friend in London is not experiencing the same present as you. Your partner in the next room is not, strictly speaking, in the same now as you. The concept of a shared present moment across any distance whatsoever is physically meaningless. And if that does not disturb you, you have not thought about it long enough. Because Stein's objection does not save presentism, it does not restore a flowing universal time. It saves nothing. It merely replaces the block universe with something equally alien, a reality in which the only thing that is definitely real for you is what has already reached you at the speed of light. Everything else, including the person sitting next to you, exists in an indeterminate ontological limbo until their light cone intersects yours. There is something else that happened in 1908, the same year Minkowski declared time a shadow. On the other side of the English Channel, a Cambridge philosopher named John MacTaggart Ellis MacTaggart published a paper called The Unreality of Time in the journal Mind. MacTaggart was, by all accounts, one of the strangest people in the history of academia. He was expelled from his preparatory school for loudly proclaiming atheism as a child. He refused to play football, preferring to lie in the middle of the field. He transported himself by tricycle and had a habit of saluting cats whenever he encountered them. He was described as having a big head and a crab-like walk, but his argument was ferocious. MacTaggart distinguished two ways of ordering events in time. The B series orders events by permanent relations, earlier than, later than, simultaneous with. These relations never change. The Battle of Hastings is always earlier than the French Revolution. It was earlier than the French Revolution 1,000 years ago. It will be earlier than the French Revolution 1,000 years from now. This relation is fixed, eternal. It is a geometric fact about the arrangement of events, not a dynamic property that shifts. The A series is different. The A series orders events as past, present, or future, and these properties constantly shift. The Battle of Hastings was once future. Then it was present. Now it is past. These properties are not permanent. They change, and McTaggart argued that this change, this movement of events from future to present to past, is what we actually mean by time. The B series, by itself, is just a static ordering. It does not flow. It does not pass. If all you have is the B series, then time is a spatial dimension, a direction you can point along, but nothing actually happens along it. For anything to actually happen, you need the A series. You need the present to be special. You need events to acquire and lose the properties of pastness, presentness, and futurity. McTaggart then argued that the A series contains a fatal contradiction. Every event must possess all three properties, past, present, and future, yet these properties are mutually exclusive. The standard defense is that events have these properties at different times, but this merely pushes the problem back, introducing a new A series that faces the same contradiction, an infinite regress. The conclusion arrived at through pure logic with no reference to physics. Time is unreal. Minkowski and McTaggart, in the same year, from completely different directions, one using mathematics and physics, the other using logic and philosophy, arrived at the same conclusion. Time is not what you think it is. And in both cases, the world nodded politely and carried on as though nothing had happened. There is a misconception you need to let go of before we continue, because it is the misconception that allows people to avoid the block universe even after they have seen the evidence. The misconception is that the block universe is just a philosophical interpretation of relativity, that it is one possible way of reading the equations, and there are other, equally valid ways that preserve the flow of time and the reality of now. This is not true. The block universe is the direct logical consequence of two premises. The first is that special relativity is correct, and in particular, the relativity of simultaneity is a real feature of the universe. The second is that no inertial reference frame is privileged over any other. Every experiment conducted in the last 120 years has confirmed both of these premises to extraordinary precision. To avoid the block universe, you must reject one of them. You must either say that special relativity is wrong about simultaneity, which means rejecting the most confirmed theory in physics, or you must say that there is a preferred reference frame, a hidden absolute now, that the equations do not reveal, which means postulating an undetectable structure that no experiment has ever found evidence for. Some physicists do take this second route. There are neo-Lorentzian interpretations of special relativity that preserve a preferred frame. They reproduce all the same predictions as Einstein's theory, but they add a structure, the preferred frame, that does no empirical work. It exists solely to save the furniture of our temporal intuitions. And in science, adding invisible structures to save intuitions is not explanation. It is denial. This was 1908. The evidence has only gotten stronger since then. The fact that you were never told any of this in school should bother you, but arguments are arguments. Logic is logic. What really makes the block universe impossible to dismiss is what happened when people started running experiments. Because the experiments did not just support the theory, they confirmed it to a precision that makes doubt unreasonable. In October of 1971, a physicist named Joseph Hafele and an astronomer named Rietdijk-Putnam did something that sounds like a thought experiment, but was entirely real. They obtained $8,000 from the Office of Naval Research, $7,600 of which went to airline tickets, bought seats on commercial flights for 4 cesium-beam atomic clocks, and flew those clocks around the world. The clocks flew under the passenger name Mr. Clock. They had their own seats. This is not a joke. This is how one of the most important experiments in the history of physics was conducted. The eastward trip departed Washington Dulles on October 4th, stopped in London, Frankfurt, Istanbul, Beirut, Tehran, New Delhi, Bangkok, Hong Kong, Tokyo, Honolulu, Los Angeles, and Dallas, and returned on October 7th. Average speed, 243 meters per second. Average altitude, 8.9 kilometers. The westward trip departed October 13th, routing through Los Angeles, Honolulu, Guam, Okinawa, Taipei, Hong Kong, Bangkok, Bombay, Tel Aviv, Athens, Rome, Paris, Shannon, and Boston, returning October 17th. When the clocks came back, Hafele and Keating compared them to the reference clocks at the Naval Observatory. The eastward clocks had lost 59 nanoseconds. The westward clocks had gained 273 nanoseconds. The predictions from Relativity were a loss of 40 nanoseconds eastward and a gain of 275 nanoseconds westward. The results matched within experimental uncertainty. The paper was published in 2 companion articles in Science, volume 177, on July 14, 1972. 59 nanoseconds, that is 59 billionths of a second, a duration so short that light itself travels less than 18 meters in that time. And yet, it was measurable. It was real. It was not a rounding error or an instrument glitch. It was a genuine physical difference in the amount of time that had elapsed for the traveling clocks versus the stationary ones. The clocks that flew east experienced less time. The clocks that flew west experienced more. When they were reunited, they disagreed about how much of the universe had happened. Think about what this means. Clocks that were synchronized before the trip disagreed after the trip, not because they malfunctioned, because time itself ran at a different rate for each clock, depending on its velocity and its altitude. The eastward clocks were moving faster relative to Earth's center of mass, which means time ran slower for them. The westward clocks were moving slower relative to Earth's center, and they sat higher in the gravitational field. So time ran faster for them. When they reconvened, they had experienced different amounts of time, not different readings, different amounts of actual physical time. This was 1971. $8,000 commercial airline seats. And the result was that time is not universal. But you do not need to fly around the world to prove this. You carry the proof in your pocket. The global positioning system, the technology that tells you when to turn left runs on a constellation of at least 24 satellites orbiting at roughly 20,200 kilometers above Earth's surface, moving at about 3.87 kilometers per second. And those satellites have a problem. Their clocks do not agree with yours. Two effects are competing. Special relativity says the satellite clocks should run slower than yours because they are moving faster. This accounts for a loss of about 7 microseconds per day. But general relativity says the satellite clocks should run faster because they are higher up in Earth's gravitational well, where space-time is less curved. This accounts for a gain of about 45 microseconds per day. The net effect is that satellite clocks gain roughly 38 microseconds per day compared to clocks on the ground. 38 microseconds sounds trivial. It is not. Light travels about 11 kilometers in 38 microseconds. If GPS did not correct for relativistic time dilation, your position estimate would drift by about 11 kilometers every single day. Within a few minutes of turning on your phone, your navigation would be useless. The correction is built into the system at the hardware level. Before launch, the onboard oscillator in every GPS satellite is set to run at 10.2299954 MHz instead of the nominal 10.23 MHz. That tiny frequency adjustment compensates for the fact that time runs at a different rate in orbit than it does on the ground. Every time you use GPS, you are relying on the fact that Einstein's dissolution of universal time is correct. This is not a philosophical position. It is an engineering requirement. The technology does not work without it. And what the technology is telling you, silently, every time it gives you an accurate position, is that there is no universal clock. There is no single rate at which time passes. And if there is no single rate, then there is no universal now. And if there is no universal now, then the past and future are not categorically different from the present. They are just at different coordinates. This fact should be printed on every phone sold on Earth. It is not. The most common piece of technology in human history, used by billions of people every day, works because time is not what you think it is, and the manufacturers never mention this. You use a device that functions only because the block universe is real, and you do it while assuming the block universe is not real. The dissonance is extraordinary, but the experiments did not stop with GPS. They kept getting more precise, and every increase in precision confirmed the same thing. The experiments kept getting more precise. In 1941, Bruno Rossi and David Hall measured cosmic ray muons on Mount Washington in New Hampshire. Muons are unstable particles with a rest frame lifetime of just 2.2 microseconds. At the speed of light, that gives them a range of about 660 meters before they decay. They are created when cosmic rays hit the upper atmosphere at altitudes of 10 to 20 kilometers. They should never reach the ground, but they do in enormous numbers because they are traveling at 99.5% of the speed of light. And at that velocity, time dilation stretches their lifetime by a factor of about 9. The Frisch-Smith experiment in 1963 measured this directly. At the top of the mountain, they counted a certain muon flux. At the bottom, instead of the 27 muons per hour that should survive without time dilation, they counted 412. The measured time dilation factor was 8.8 plus or minus 0.8. consistent with the relativistic prediction. In 1977, the CERN muon storage ring experiment, published in Nature, confirmed time dilation for muons at a Lorentz factor of 29.33, with muons subjected to accelerations of more than 10 to the 18th g. The acceleration made no difference. Time dilation depends only on velocity, exactly as Einstein predicted. This is worth pausing on. 10 to the 18th g is a billion times the force of gravity at Earth's surface. The muons were being whipped around a storage ring at nearly the speed of light, subjected to forces that would flatten a building to the thickness of an atom. And the time dilation was still exactly what special relativity predicted. No deviation, no anomaly, no hint of a preferred frame or a universal clock hiding behind the scenes. The experiments are not ambiguous. They do not leave room for interpretation. Time runs at different rates, depending on velocity and gravitational field strength. This is not a measurement artifact. It is not a result of clocks being affected by motion. It is time itself, the actual rate at which physical processes unfold, including the decay of unstable particles, the ticking of atomic clocks, and the aging of biological organisms. If you could somehow travel at 99% of the speed of light for what felt to you like a year, you would return to find that 7 years had passed on Earth, not because your perception was altered, because less time actually elapsed for you. You would be genuinely, biologically younger than your twin who stayed home. This is not science fiction. This is measured fact. And then, in February of 2000, Julian's team at GILA, a joint institute of the National Institute of Standards and Technology and the University of Colorado Boulder, published a result in Nature that should have been front-page news everywhere and was not. They measured gravitational time dilation across a height difference of approximately 1 millimeter. 1 millimeter, the width of a pencil tip, the thickness of a credit card, a distance so small you could not see it from across the room. The experiment used an optical lattice clock containing roughly 100,000 ultra-cold strontium atoms held in layers by laser beams. The atoms were cooled to near absolute zero, to temperatures measured in billionths of a degree above the coldest possible temperature in the universe. At these temperatures, the atoms are nearly motionless, and their quantum properties become exquisitely sensitive to the geometry of space-time around them. By splitting the cloud of atoms into a top stack and a bottom stack separated by 1 millimeter, and measuring the frequency difference between them over 90 hours of data collection, they resolved a gravitational redshift on the order of 10 to the negative 19th. That is a difference of 1 part in 10 billion billion. The atoms at the top of the stack aged faster than the atoms at the bottom. Not by much, by an amount so small it took 90 hours to measure, but the difference was there. Real. Confirmed. Published. The previous record for the smallest height at which gravitational time dilation had been measured was held by David Wineland's group at NIST, who in 2010 measured the effect across a height difference of 33 centimeters, about a foot. Julian's team beat that by a factor of roughly 300. Time is not merely relative at cosmic scales, or at satellite altitudes, or at the height of a mountain. It is relative across the width of a pencil tip. Think about what that means for you. You are roughly 1.7 meters tall. The atoms in your head are aging faster than the atoms in your feet, not metaphorically, measurably. Your head has always been slightly older than your feet. The difference is absurdly small, on the order of femtoseconds over a lifetime. But it is physically real. And the reason it matters is not the size of the effect. It is what the effect proves. Time is not a river flowing at a constant rate. Time is a geometric property of space-time, and it varies from point to point depending on where you are and how you are moving. It is not that your clock runs differently from mine. It is that time itself is different for you and for me. There is no single now that we share, and the technology keeps improving. Julian told reporters after the Gila result, "If we could measure the redshift 10 times even better than this, we will be able to see the atom's whole matter waves across the curvature of space-time." The clocks are approaching a resolution where they could observe individual atoms existing in curved space-time, where the geometry of the block becomes visible at the scale of a single particle. Every improvement in precision confirms the same thing. Time is geometry, and geometry does not flow. What flows is your experience. What flows is the story your brain tells you. And the story, as we are about to see, has no basis in the fundamental equations. Before we get there is something you need to understand about the people who realized all of this first, because the experiments confirm the block universe. The math requires it. The logic is airtight. But the people who actually followed the reasoning to its conclusion, who took it seriously, not as a calculational trick, but as a description of what reality actually is, paid for that understanding with their careers, their reputations, and in one case, their lives. This is where the story usually ends in popular science. Time is relative. Einstein was right. GPS proves it. Here is a cool experiment. Moving on. But that is not the end. That is barely the beginning. Because the people who actually understood what all of this meant, who followed the logic to its conclusion, who looked at what the equations actually say about the nature of time, paid a price for that understanding. And the physics establishment, almost without exception, refused to listen. There is a photograph that people who study the history of physics know well. Two men walking together along Mercer Street in Princeton, New Jersey. Sometime in the late 1940s, one is Albert Einstein, rumpled, wearing baggy pants and suspenders, no socks, his white hair wild. The other is Kurt Godel, dapper, precise, dressed in a white linen suit with a matching fedora, looking like he might be on his way to a formal dinner rather than a stroll through a college town. They walked this route nearly every day, from Einstein's house at 115 Mercer Street to the Institute for Advanced Study and back, talking in German, arguing about physics and philosophy and the nature of time. The walks lasted about half an hour each way, and they continued for years, through heat and rain and the bitter Princeton winters. The other members of the Institute watched these walks with a mixture of awe and bewilderment. Here were the two most penetrating intellects of the 20th century, one the destroyer of absolute space and time, the other the destroyer of mathematical certainty, walking side by side through the suburbs of New Jersey, debating the fundamental nature of reality as though it were a puzzle that might yield to one more good conversation. Freeman Dyson, who was at the Institute during this period, later wrote that Godel was the only one of our colleagues who walked and talked on equal terms with Einstein. This is an extraordinary statement when you consider that the Institute for Advanced Study in the 1940s was perhaps the greatest concentration of intellectual talent in human history. John von Neumann was there. Robert Oppenheimer directed the place. Freeman Dyson himself was there. And yet, Godel was the only one Einstein considered a genuine peer. Near the end of his life, Einstein told the economist Oscar Morgenstern something that sounds almost like a confession. He said that his own work no longer meant much to him, that he came to the Institute merely to have the privilege of walking home with Godel. This was Einstein, the man whose name had become the very word for genius, the man who bent space-time and split the atom's theoretical foundations, saying that the most valuable thing remaining in his professional life was a daily walk with a logician who believed time was an illusion. To understand why, you need to know who Godel was and what he did. Kurt Godel was born on April 28, 1906, in Brunn, which is now Brno in the Czech Republic. His family called him Herr Warum, Mr. Why, because of his relentless childhood questioning. At 25, he proved the incompleteness theorems, which are, without exaggeration, the most important results in the history of mathematics. He showed that, in any consistent formal system complex enough to express basic arithmetic, there are true statements that cannot be proved within the system. Mathematics cannot prove its own consistency. The implications were devastating. David Hilbert's program to establish the complete logical foundations of mathematics was dead. Godel killed it with a theorem. He fled Nazi Austria in 1940, taking an extraordinary route that reads like a thriller. With his wife Adele, Godel traveled by train across the entire breadth of the Soviet Union on the Trans-Siberian Railway, from Moscow to Vladivostok, a journey of over 9,000 kilometers. From Vladivostok, they sailed to Yokohama, Japan, and from there across the Pacific to San Francisco. The entire journey took weeks. They were fleeing a continent that was descending into the worst catastrophe in human history, and they did it by crossing the largest country on Earth and the largest ocean on Earth, arriving at Princeton, where Godel would spend the rest of his life. He never returned to Europe, and it was there, in the quiet of the Institute, on those daily walks with Einstein, that Godel turned his attention from mathematics to physics, specifically to the nature of time. He later told a friend that the nature of time was the philosophical question. In 1949, Godel published his answer. It was presented as a birthday gift for Einstein's 70th birthday, and it was, in the most literal sense, a weapon disguised as a present. The paper, an example of a new type of cosmological solutions of Einstein's field equations of gravitation, appeared in reviews of modern physics. The companion philosophical paper, a remark about the relationship between relativity theory and idealistic philosophy, appeared in the Schilp volume Albert Einstein, Philosopher-Scientist. What Godel did was find a new solution to Einstein's own field equations of general relativity. The Godel metric describes a universe that is rotating, homogeneous, and stationary, and this universe has a feature that Einstein's equations apparently permit, but that nobody wanted to think about. It contains closed time-like curves, paths through space-time that loop back to their own starting point. Time travel. Not as science fiction, not as a thought experiment, as a mathematical consequence of the equations that describe gravity. In the Godel universe, there is no consistent way to define before and after. There is no global time function. You cannot slice the space-time into a sequence of moments because the structure loops back on itself. Time in the Godel universe does not exist as a physical feature of reality, but here is the part that was truly devastating, and the part that the physics community has spent 75 years trying not to deal with. Godel's argument was not that our universe is rotating. It probably is not. Godel's argument was about what the existence of his solution tells us about the nature of time in all universes governed by Einstein's equations, including ours. The argument goes like this: for time to be real, there must be an objective sense in which events happen, in which there is genuine becoming. In the Godel universe, no such objective temporal ordering exists, but the Godel universe is a valid solution to the same equations that describe our universe. Whether time is real should not depend on the accidental distribution of matter. The equations are the same. The structure they describe should have the same fundamental nature. If time can be illusory in one solution, it is illusory in all of them. This is a devastating argument, and the usual rebuttals do not survive contact with it. The most common rebuttal is that our universe does not rotate, so the Godel solution is physically irrelevant. Godel anticipated this objection and dismissed it. The point is not about rotation. The point is about what the equations permit. General relativity is supposed to describe the fundamental nature of spacetime. If the fundamental nature of spacetime can lack an objective time ordering, then time ordering is not fundamental. It is contingent, an accident, something that appears in some solutions and not in others. You would not say that electricity is a fundamental feature of Maxwell's equations if there were valid solutions to Maxwell's equations that contained no electric field. You would say the electric field is a feature of certain configurations, not of the theory itself. Godel applied exactly this reasoning to time, and nobody has refuted it. Godel wrote, "Each observer has his own set of nows, and none of these various systems of layers can claim the prerogative of representing the objective lapse of time." Einstein's response, published in the same volume, was cautious. He acknowledged that the mathematics was correct. In that case, the distinction earlier-later is abandoned for world points which lie far apart in a cosmological sense. But he hedged, it will be interesting to weigh whether these are not to be excluded on physical grounds. Translation: the math is right, but maybe we can find a reason to ignore what it means. The physics community took Einstein's hedge and ran with it. They acknowledged the Godel metric as a valid mathematical solution and then treated it as a curiosity, a strange corner case with no real implications for our understanding of time. This is still the standard response. Godel's solution. Interesting. Moving on. But Godel never moved on. He could not. The logic was airtight. The philosopher Hafele-Keating, who has written extensively about Godel and Einstein, called the result a bomb lobbed into the foundations of physics, and the bomb was never diffused. It was just ignored. What happened to Godel after this is a story that mirrors the discomfort of his discovery. He had always been eccentric, but over the decades at Princeton, his eccentricities curdled into something darker. The seeds of his paranoia may have been planted early. In 1936, the philosopher Moritz Schlick, leader of the Vienna Circle and someone Godel knew personally, was murdered on the steps of the University of Vienna by a former student. The murder shook Godel profoundly. He suffered his first nervous breakdown shortly after. His paranoia deepened over the years into a fixed certainty that he was being poisoned. He developed elaborate precautions around food. Eventually, he would only eat food that was prepared by his wife Adele, and that she had first tasted herself. Adele Godel, born Adele Paulkert, was a former nightclub dancer 6 years older than Kurt. They married in 1938 against the wishes of his family. She was, by all accounts, warm, practical, tough, and completely devoted to him. She was also the only thing standing between Kurt Godel and starvation. There is a wonderful story about Godel's American citizenship examination that reveals exactly how his mind worked and why it both elevated and destroyed him. On December 5, 1947, Einstein and Morgenstern drove Godel to the courthouse in Trenton, New Jersey, to serve as his character witnesses. In the car on the way there, they tried to keep the conversation light. They knew what Godel had been doing in preparation for the exam. He had been studying the United States Constitution with the same rigor he brought to mathematical logic, and he had found something. A logical inconsistency, a pathway within the Constitution's own amendment process that could, in theory, allow the legal establishment of a dictatorship without violating a single constitutional provision. Einstein and Morgenstern were alarmed. They knew that if Godel brought this up during the exam, the judge might refuse him citizenship. They spent the car ride trying to distract him. They told jokes. They changed the subject. It did not work. When the judge, Philip Foreman, made the polite small talk observation that the American system of government was designed to prevent dictatorship, Godel could not contain himself. He interrupted to explain, with the enthusiasm of a mathematician who has found an elegant proof, exactly how the Constitution permitted the thing it was supposed to prevent. Einstein and Morgenstern reportedly exchanged a look of horror. The judge, to his eternal credit, sensed the situation, steered the conversation elsewhere, and granted citizenship. The irony is fitting. Godel could find the flaw in any system, constitutional or mathematical or cosmological. This was his gift. It was also the thing that destroyed him. In late 1977, Adele suffered a stroke and was hospitalized for an extended period. Without her, Godel would not eat. He could not trust anyone else not to poison the food. He was admitted to Princeton Hospital, where he continued to refuse food. On January 14, 1978, Kurt Godel, the cause of death, was listed as malnutrition and inanition caused by personality disturbance. He weighed 29 kilos, 65 pounds, the greatest logician since Aristotle starved to death because he could not trust the world enough to sustain his own body. And the question he never stopped asking, whenever Godel encountered an astronomer, he would ask, "Is the universe rotating yet?" The answer was always no. Our universe, as far as we can tell, does not rotate. The Godel metric does not describe our cosmos. But Godel understood something that the people answering his question did not. The question was not about rotation. It was about what the existence of the rotating solution implies. If Einstein's equations allow a universe with no time, then time is not a fundamental feature of Einstein's equations. It is an accident, a contingency, something that might appear in one solution and not in another. And you cannot build a fundamental reality on an accident. The man who proved time is an illusion died in a timeline he did not believe existed, of a paranoia he could not escape. in a body that wasted away because his mind would not let him trust the world. If the block universe is real, then Kurt Godel is still there at Princeton, still walking with Einstein, still asking whether the universe is rotating. And he is also still starving. Both of these moments exist permanently at their coordinates in the block. The block does not distinguish between the walk and the starvation. It contains both. It releases neither. There is a detail about Godel's death that rarely appears in the popular accounts and that is worth sitting with. His death certificate lists his weight at the time of death as 29 kilograms. He was 5 feet 6 inches tall. At 29 kilos, you can see every bone. The skin hangs, the eyes recess. The greatest logician since Aristotle, the man who destroyed Hilbert's program, the man who proved the incompleteness of mathematics and the illusoriness of time, ended his life as a skeleton in a hospital bed in Princeton, New Jersey, because the same relentless logical mind that could find the contradiction in any system also found threats everywhere. He could not stop reasoning. He could not stop finding the flaw. And the final flaw he found was in the food. There might be poison. The logic said so. And logic, for Godel, was the only thing that could be trusted. More than people. More than his own body. More than survival. If you want to understand what it costs to take the block universe seriously, to follow the equations wherever they lead, to refuse the comfortable fiction that time flows and things change and the past is gone, look at Godel. He did not just argue that time is an illusion. He lived as though it were true, and it consumed him. But Godel was not the only person who took the block universe seriously and paid a price for it. Julian Barbour was born in England in 1937. He earned his PhD in physics from the University of Cologne in 1968, and then did something almost unprecedented in modern theoretical physics. He never took an academic position, not because he could not, because the academic system could not accommodate the question he was asking. For over 30 years, Barbour supported himself by translating Russian scientific articles for the American Institute of Physics and Plenum Publishing. He worked from a farmhouse near Banbury in North Oxfordshire, while tenured professors at Cambridge and Princeton spent their careers within the boundaries of accepted research programs. Barbour sat in his farmhouse and asked whether time exists. He concluded that it does not. His book, The End of Time, The Next Revolution in Physics, published by Oxford University Press in 1999, lays out the argument in detail. What we experience as the passage of time, Barbour argues, is really a series of instantaneous configurations he calls nows. These are not moments in a sequence. They are points in a timeless landscape he named Platonia, after Plato's realm of eternal forms. Every possible configuration of the universe exists as a point in Platonia. What we call the Big Bang is not an explosion that happened in the past. It is a specific location in this timeless space, a point Barbour calls alpha, which has special geometric properties. The sense that time flows from the Big Bang to now is an illusion produced by the structure of the nows and the way records of the past are contained within each configuration. What makes this idea remarkable is not just that it is radical. It is that Barbour can derive real physics from it. With the Italian physicist Bruno Bertotti, Barbour developed in 1982 a mathematical technique called best matching that derives the equations of gravity without any reference to a background spacetime. No absolute time, no absolute space, just relations between configurations. The equations reproduce general relativity with complete accuracy. The physics works without time. This is not philosophy, it is calculation. You can take Barbour's framework, do the math, and get the same predictions as general relativity for every experiment ever conducted. The time variable drops out of the equations and nothing is lost. In 2014, working with Tim Kozlowski and Flavio Mercati, Barbour published a paper in Physical Review Letters proposing a gravitational origin for the arrow of time. His more recent book, The Janus Point, develops this idea further. He argues that the universe has a special point of minimum complexity, and that complexity increases in both temporal directions away from this point, producing two arrows of time pointing in opposite directions. Beings on either side would experience time as flowing away from the Janus point, and both would be right, and neither would be perceiving anything fundamental about reality. Barbour is now in his late 80s. He still works from Oxfordshire. He still has never held an academic position, and the mainstream still treats his work as interesting but peripheral, the way you might treat a gifted amateur who has accidentally stumbled onto something important. The condescension is misplaced. Barbour has published in the same journals as everyone else. His mathematics is rigorous. His predictions match experiment. The only thing the mainstream objects to is his conclusion, and they object to it not because it is wrong, but because it is uncomfortable. The pattern is consistent. Einstein said time is an illusion in a private letter. Minkowski said it publicly and died before the implications could be processed. Rietdijk-Putnam proved it formally and were published in philosophy journals that physicists do not read. Godel proved it using Einstein's own equations and was treated as an eccentric. McTaggart proved it using pure logic and was treated as a curiosity. Barbour derived real physics without time and was treated as an outsider. The conclusion is always the same. The evidence is always acknowledged, and the implications are always avoided. This is not a fringe position that serious physicists reject. It is a mainstream result that serious physicists accept mathematically and then refuse to discuss publicly. The block universe is the elephant in the lecture hall. Everyone knows it is there. Nobody wants to be the one who points at it and says what it means for the students sitting in the chairs. The gap between what the physics says and what physicists are willing to say out loud is one of the most remarkable features of modern science. And that gap is about to get much wider, because the story does not end with relativity. It does not end with Godel. It does not end with Barbour sitting alone in his farmhouse, translating Russian papers to fund his assault on time. There is an equation. Almost nobody outside of theoretical physics has heard of it. It is arguably the most important equation in physics that the public knows nothing about. It was written down in 1967, and it contains a revelation about the nature of time that makes everything you have heard so far sound like a prelude. The equation has no time variable, none. It emerged from a chance encounter at an airport. In 1965, the physicist John Archibald Wheeler was waiting for a flight at Raleigh-Durham Airport in North Carolina when he ran into Bryce-DeWitt. Wheeler was one of the great figures of 20th century physics. He coined the term black hole. He had worked on the Manhattan Project. He had mentored Richard Feynman. He had an almost poetic sensibility about physics a tendency to phrase technical questions in language that made them feel urgent and personal. His most famous question was, "How come the quantum?" followed by, "How come existence?" He had spent decades thinking about how to reconcile quantum mechanics and general relativity into a single framework. And he had gotten nowhere. Nobody had. The conversation at the airport became legendary in theoretical physics. Wheeler laid out the problem with characteristic intensity, and DeWitt, who had been working on quantum gravity from a different angle, took it up. The result, published 2 years later, would become the most important equation that the public has never heard of. The problem is deceptively simple to state. Quantum mechanics, which governs atoms and particles and everything at small scales, uses the Schrödinger equation. That equation has a time variable in it, the familiar t that tells you how a quantum state evolves from one moment to the next. You start with a state at time 0. You apply the equation and you get the state at time 1. The universe ticks forward. General relativity, which governs gravity and the large-scale structure of space-time, treats time as a dimension, not a background parameter through which things evolve, but a part of the thing itself. Space-time curves, time bends. The geometry is dynamic. When you try to combine the two, when you try to write a quantum mechanical description of the entire universe, including its own gravitational field, you are trying to quantize the very stage on which quantum mechanics is normally performed. You are trying to make time quantum mechanical. And when DeWitt actually did this, publishing the result in 1967 in the journal Physical Review, the equation he got was nothing like the Schrödinger equation. It looked like this: H psi equals 0. That is it. That is the equation for the universe. The Hamiltonian operator acting on the wave function of the universe equals 0. 5 symbols, and inside those 5 symbols is a statement about reality that should have changed civilization. Compare this to the Schrödinger equation, where H psi equals I H bar times the partial derivative of psi with respect to t. The right side of the Schrödinger equation is where time lives. It is the engine that drives change. It is what tells you that the quantum state at this moment is different from the quantum state at the next moment. In the Wheeler-DeWitt equation, the right side is 0. There is no partial derivative with respect to t. There is no t. The wave function of the universe does not evolve. It does not change. It does not go from one state to another. It simply is. This is called the frozen formalism problem, and it has been the central unsolved puzzle of quantum gravity for nearly 60 years. The most fundamental equation we can write for the universe as a whole contains no reference to time whatsoever. The universe, described at its deepest level, is static, frozen, a block, not block-like, not analogous to a block, a timeless, changeless, complete structure that contains everything that has ever happened and everything that ever will, and in which nothing is happening, because happening requires time, and the equation has none. And here is the part that nobody wants to say out loud. This is not a bug. It is not a mathematical error. It is not an artifact of an incomplete theory that will be fixed when someone finds the right approach. The Wheeler-DeWitt equation is the natural, inevitable result of applying the standard rules of quantum mechanics to the standard equations of general relativity. Both of those theories are the most experimentally confirmed frameworks in the history of science. Quantum mechanics has never made a wrong prediction. General relativity has never made a wrong prediction. When you combine them using the standard procedure that works for every other quantum field theory, time disappears. That is what the combination says, and physicists have spent 60 years trying to explain it away, or work around it, or reinterpret it, or dismiss it as a sign that the quantization procedure needs modification. But the equation remains. H psi equals 0. The universe does not evolve. The universe does not change. The universe is. The most famous attempt is the Page-Wouters mechanism, introduced by Don Page and William Wouters in 1983. Their idea is elegant and disturbing in equal measure. If you divide the universe into two subsystems, one of them can serve as a clock for the other. Time emerges not as a fundamental feature of reality, but as a relationship between parts of the universe. When you ask, "What time is it?" you are really asking about correlations, the position of the hands on your watch, the number of oscillations in a cesium atom, the angle of the sun. These are not measurements of some external, flowing time. They are measurements of one part of the universe correlated with another part. The universe as a whole is timeless, but from inside, using a clock made of atoms, it looks like things are happening in sequence. In 2013, Ekaterina Moreva and colleagues at the Istituto Nazionale di Ricerca Metrologica in Turin published an experimental test of the Page-Wouters mechanism using entangled photons. They created a system where an external observer saw no evolution, a static, timeless state, while an internal observer, correlated with a clock photon, saw the system evolving in time. Both descriptions were correct. Time was real for the internal observer and non-existent for the external one. The paper was published in Physical Review A. The result was exactly what Page and Wouters had predicted 30 years earlier. Read that again. An experiment conducted in a laboratory confirmed that time can be both real and unreal, depending on whether you are inside or outside the system. From inside, things happen. From outside, nothing happens. The universe, seen from outside, is frozen. The universe, seen from inside, flows. And both of these descriptions are physically correct. Both are verified by experiment. The difference is not about truth. It is about perspective. Time is not out there. Time is in here. It is a perspective, not a property. Think about what this means for you, sitting where you are right now. The experience of time passing. The feeling that this moment is yielding to the next moment, that the words you just read are now in the past, and the words you are about to read are approaching from the future, might be nothing more than a correlation between different parts of a static quantum state. Your brain is one subsystem. The clock on your wall is another. The correlations between them produce the experience of sequence. But the total state, the wave function of everything, is not changing. It is not ticking. It is not flowing. It is sitting there, complete, containing all the correlations at once. The movie is not playing. The movie is all of it, every frame, and the characters inside each frame have the strong impression that the movie is playing because each character has memories of the previous frames and expectations about the next ones. But the projector is off. There is no projector. There was never a projector. The clock ticks. Your brain registers the tick. Your memory records the sequence of ticks, and you conclude that time has passed. But nothing has passed. the entire structure, the clock at all its positions, your brain in all its states, your memories at all their stages of formation, exist simultaneously in the timeless wave function. The sense of sequence is internal to the pattern. It is not a feature of the pattern itself. Carlo Rovelli, the Italian physicist who co-founded loop quantum gravity, proposed another approach to the problem in 1993 with the mathematician Alain Connes. They called it the thermal time hypothesis. Rovelli's biography is itself a story of unlikely paths. In the 1970s, he was a student activist in Italy, involved in the radical free radio movement, broadcasting from pirate stations like Radio Alice in Bologna and Radio Anguana in Verona. These were illegal transmitters operated by the far left during the turbulent years of Italian political upheaval, and they were eventually shut down by police. When the political movement collapsed under state repression and internal contradictions, Rovelli turned to physics with the same intensity he had brought to politics. He has said that physics became a way to continue asking radical questions about reality after politics had failed to change it. With Lee Smolin and Abhay Ashtekar, he developed loop quantum gravity as an alternative to string theory in the late 1980s, and he has spent decades thinking about what the disappearance of time from fundamental physics actually means for human beings who experience it every moment of their lives. Rovelli and Connes argued that time is not fundamental, but thermodynamic. Here is the argument. Look at every fundamental law of physics: Newton's laws, Maxwell's equations, Einstein's field equations, the Schrödinger equation, the Dirac equation. Every single one of them is perfectly symmetric in time. They work exactly the same, running forward as running backward. A video of two billiard balls colliding looks perfectly physical whether you play it forward or in reverse. The fundamental laws do not distinguish past from future. The only law in all of physics that distinguishes past from future is the second law of thermodynamics, the observation that entropy, the measure of disorder, tends to increase. And the second law is not fundamental. It is statistical. It emerges from the behavior of large numbers of particles. It is a statement about what is probable, not about what is physically required. Rovelli's conclusion is that time itself is statistical. It appears only because we are macroscopic creatures who see a coarse-grained version of reality. We cannot track the individual motion of every particle. We see averages, aggregates, trends, and in that averaged picture, entropy increases, disorder accumulates, and the asymmetry we call the direction of time emerges. Strip away the averaging, look at the fundamental equations, and the direction vanishes. Past and future become indistinguishable. Time loses its arrow, and the block sits there, symmetric, silent, containing everything. This is perhaps the most underappreciated fact in all of science. Every fundamental law of physics works the same way, forward and backward in time. If you filmed two particles interacting according to the fundamental forces and played the film in reverse, the reversed interaction would be a perfectly valid physical process. The fundamental laws cannot tell you which way the film is running. The only reason you can tell, the only reason you experience a direction of time at all, is entropy. And entropy is not a law in the way that gravity is a law. It is a statement about probability. It says that there are overwhelmingly more high entropy states than low entropy states. So random motion tends toward disorder. That is it. The entire arrow of time, the entire difference between yesterday and tomorrow, between memory and anticipation, between cause and effect as you experience them, rests on a statistical tendency. Remove the statistics, look at the fundamental level, and time has no direction. The block does not point. Rovelli wrote about this in The Order of Time, published in 2018. The audiobook was narrated by Benedict Cumberbatch, which tells you something about where the culture places this topic, somewhere between physics and performance, between knowledge and entertainment. But the content is not entertainment. Rovelli wrote, "This is time for us, memory, and nostalgia, the pain of absence, beautiful words, and terrifying ones, because what Rovelli is saying, underneath the poetry, is that the flow of time is a story your brain tells you, generated by thermodynamics and neurological processing, about a reality that does not actually flow. The neuroscience makes it worse." David Eagleman at Stanford has spent years studying how the brain constructs the experience of time, and his results should unsettle anyone who trusts their own perception of the present moment. The brain does not perceive time the way it perceives light or sound. There is no time organ. There is no dedicated sensory system that detects the passage of moments. Instead, the brain assembles the experience of time from multiple sensory inputs that arrive at different speeds. Light reaches your retina faster than pressure reaches your fingertip. Sound is processed on a different timeline than vision. The brain waits approximately 100 milliseconds for the slowest relevant input to arrive, and then constructs a unified, temporally coherent experience of now. Your present moment is not a point. It is a manufactured window, roughly 100 milliseconds wide, stitched together after the fact from inputs that did not actually arrive simultaneously. It gets stranger. Ernst Poppel, a German neuroscientist, has proposed that each conscious moment spans approximately 3 seconds, what William James called the specious present. The philosopher Robert Kelly named this concept in 1882, and James developed it further in his Principles of Psychology in 1890. The point is that the continuous flow of experience you feel is not continuous. It is discrete. It is assembled from islands of awareness roughly 3 seconds long, each one constructed retrospectively by a brain that has no direct access to time itself. The brain even engages in postdiction, a process where stimuli arriving slightly later can retroactively alter your conscious perception of events that happened earlier, within a window of about 200 milliseconds. This is not a metaphor. This is experimentally verified. In the flash lag effect, for instance, a moving object's perceived position at the moment of a flash is shifted in the direction of its motion, as if the brain is projecting forward. In the color phi phenomenon, the brain fills in motion and color changes between two discrete stimuli, creating an experience of a smooth transition that never physically occurred. Your brain is editing the past continuously in real time to produce a coherent narrative of the present, and you never notice because the editing is seamless. What this means is that your experience of time flowing is manufactured. It is a neurological construction built from delayed inputs, discrete processing windows, and retrospective editing. The now you inhabit is not a knife edge of the present slicing through reality. It is a rough estimate, a best guess, a narrative produced by a brain that evolved to keep you alive not to perceive the fundamental nature of reality. And what the fundamental nature of reality actually looks like, according to every equation we have, is a structure that does not flow, does not tick, does not distinguish this moment from any other. Lee Smolin disagrees, and his disagreement deserves respect because Smolin is not a crank, and his argument is not casual. His book Time Reborn, published in 2013, makes the case that physics has made a fundamental error by eliminating time from its theories. Smolin argues that the mathematical models physicists use are inherently timeless abstractions, and that the mistake is in confusing the model with reality. The map is not the territory. Just because the equations are symmetric in time does not mean reality is. The laws of physics, he claims, are not eternal. They can change. They can evolve. Time is not an illusion. It is the most fundamental feature of reality, more fundamental than the laws themselves. With the philosopher Roberto Vangabera Unger, Smolin developed this view further in The Singular Universe and the Reality of Time, published in 2015. They argue for a thick present, a genuinely existing moment that is not just a coordinate, but a real ontological boundary between a fixed past and a genuinely open future. This is a serious, internally consistent position, and it has the enormous advantage of matching human experience. But it has a problem. Every experiment ever conducted is consistent with the block universe. Special relativity eliminates absolute simultaneity. General relativity treats time as a deformable dimension. The Wheeler-DeWitt equation eliminates time entirely. The Hafele-Keating clocks confirmed it. GPS relies on it. The GIL experiment measured it to millimeter precision. To accept Smolin's position, you have to argue that all of these results are consistent with a flowing time that is somehow hidden behind the relativistic effects. You have to add structure, a preferred frame, a real present, an open future that does no empirical work. No experiment distinguishes Smolin's universe from the block. And in physics, when an entity does no empirical work, the standard practice is to cut it out. Smolin knows this. He has acknowledged that his view requires a departure from the standard interpretation of relativity. He believes the departure is justified by the severity of the problem of time in quantum gravity and by the manifest reality of temporal experience. He may be right. The history of physics is full of cases where the consensus was wrong and the dissenters were vindicated. But right now, today, in 2006, the weight of evidence sits on the other side. The equations have no time. The experiments confirm relativity. The formal proofs demand eternalism. The neuroscience reveals that temporal experience is constructed, not perceived. And the one equation that should settle everything, the Wheeler-DeWitt equation, the equation for the universe itself, stares back at us with a zero where time should be. Smolin asks us to trust our experience over the equations. The block universe asks us to consider the possibility that our experience is exactly the kind of thing a timeless structure would produce inside itself to keep its patterns from noticing that nothing is happening. There is a common misconception that the block universe means free will is impossible, that if the future already exists, your choices are predetermined, and you are just a puppet going through motions that were fixed before you were born. This deserves an honest answer, not a dismissal. The philosopher Karl Hofer, in a 2002 paper called Freedom from the Inside Out, argued that in a block universe, No time slice is the fundamental cause of any other. The block is not a domino chain where the past knocks over the present and the present knocks over the future. It is a single, self-consistent structure. Your choices are real events inscribed in the block. They are causally efficacious within the structure. The person you are, the deliberation you undergo, the decision you make, they are part of what determines the shape of the block. The block does not mean someone else wrote your story. It means the story exists as a complete object, rather than being written moment by moment. The philosopher Janan Ismail, in her 2016 book, How Physics Makes Us Free, develops this further. She argues that the block universe is actually more compatible with genuine agency than the flowing time picture, because it removes the threat of causal determinism running from the past to the future, like a lit fuse. In the block, there is no fuse. There is no chain of causation running from the Big Bang to your breakfast. There is a structure, and you are part of the structure. Your deliberation, your weighing of options, your feeling of choosing, these are real features of the block. They are part of what makes the block the shape it is. The block does not override your choices. Your choices are what the block is made of. At your coordinates. This is a sophisticated and defensible position, and it may be the best answer philosophy can give. But notice what it asks you to accept. It asks you to accept that you are not choosing in real time. You are a pattern that includes the appearance of choosing. The deliberation is real. The choice is real. But the choosing, the active verb, the sense of an open future closing into a decided present, that is the illusion. The block already contains your decision. It always did. You just cannot see far enough along your own world line to know what you decided until you get there. And getting there is itself something the block contains, not something you do. But there is a deeper problem that no amount of compatibilism can quite dissolve. If you are a static pattern in a frozen four-dimensional structure, who is doing the experiencing? Who is the entity that feels like it is progressing from birth to death? The block contains a pattern that includes memories, intentions, sensations, and the subjective feeling of temporal passage. But the block itself does not change. It does not run like a movie. It is more like every frame of the movie existing simultaneously, and each frame contains a character who remembers the previous frames and anticipates the next ones. The character feels like it is moving through the movie, but it is not. It is part of the movie, all of it, all at once, and nobody can explain why it feels like movement. The philosopher David Kyle Johnson has put the existential problem more bluntly than most. If the future already exists, he writes, then only one action is possible, and my choice is not free. The future is as set as the end of a movie I am already watching. This overstates the case, as the compatibilists have argued, but it captures the emotional vertigo of the block universe in a way that the philosophical literature often sanitizes, because the block universe does not just challenge free will in the abstract, it challenges your sense of being a person. A person, in the ordinary sense, is something that develops, something that grows, something that was one thing and is now another. In the block universe, you are not developing, you are not growing, you are not becoming anything. You already are everything you will ever be. The entire arc from birth to death, exists as a completed object, and the feeling of becoming, the sense that you are in the middle of a story that has not been written yet, is the most intimate illusion the block produces. This is sometimes called the problem of the flow of time, and it is distinct from the problem of the direction of time. The direction question asks why we remember the past, but not the future. The answer is thermodynamic, entropy. Memories are low entropy records embedded in high entropy surroundings. They can only form in the direction of increasing entropy. That is why you remember yesterday, but not tomorrow. The flow question is different and far more troubling. It asks why there is any experience of passage at all, why it feels like something to be at one moment rather than another, why consciousness seems to slide along the world line instead of perceiving the entire worm at once. Why does the 5-year-old version of you not know about the 40-year-old version? Why does each slice feel isolated, immersed in its moment, unaware that it is just one cross-section of a 4-dimensional object that stretches from birth to death? And the answer to this question is nobody knows. 60 years after the Wheeler-DeWitt equation, 120 years after Einstein's paper, thousands of years after humans first wondered about the nature of time, nobody knows why it feels like this. The block exists. The experience of flow exists. And the connection between them is the deepest unsolved problem in all of science. And this brings us back to where we started, to the letter, to the man writing to his dead friend's family, to the question that the title of this video asked, and that physics has answered in a way that should keep you awake tonight. Your past self still exists right now, not as a memory, not as an echo, not as an after-image fading in the dark, as a physical reality, as a cross-section of your 4-dimensional world line, located at specific coordinates in the block of space-time, as real and as present as the version of you that is hearing these words. The child you were at 5 years old is still there, still real, still experiencing that moment, at that location, in that configuration. The teenager lying awake at 2 a.m, afraid of something they could not name, is still lying there, still awake, still afraid. The moment you would most like to forget is still happening, not in your memory, in space-time, at its coordinates, permanently. And the moment you would most like to return to is still there, but you cannot reach it. You are not moving through the block. You are embedded in it. Each version of you is fixed at its coordinate, experiencing its moment, with no ability to reach forward or backward to the other versions. They are all you. You are all of them, and none of you can communicate across the block. Each slice thinks it is the only one that is real. Each slice is wrong. There is a passage in Kurt Vonnegut's Slaughterhouse-Five that captures this better than any physics paper. Vonnegut's Tralfamadorians, aliens who can see in 4 dimensions, perceive all moments simultaneously. When someone dies, they say that person is in bad condition in that particular moment, but still very much alive in plenty of other moments. This was written as fiction, published in 1969, but the physics of special relativity, published in 1905, had already confirmed it was not fiction at all. Vonnegut described the block universe as a novelist before most physicists were willing to describe it as physics. The Tralfamadorians were more honest than the textbooks. Einstein understood this. He understood it when he wrote that letter. He was not guessing. He was not hoping. He was not offering the kind of vague spiritual reassurance that people offer each other in the face of death. He was reporting what the physics demands, and the physics had been demanding it since 1905, since the day a 26-year-old patent clerk in Bern submitted a paper to Annalen der Physik that quietly eliminated the physical basis for the distinction between past, present, and future. Einstein spent 50 years living with that knowledge. 50 years knowing that the past is not gone, and the future is not open, and the present is not special. 50 years knowing that Michel Bessot, when he died, did not cease to exist. He ceased to exist at certain coordinates. At other coordinates, he was still having dinner, still arguing about physics, still alive. Michel Bessot died on March 15th, 1955. And if Einstein was right, and every experiment conducted in the 70 years since suggests he was, then Bessot is still there, still at his coordinates, still alive at some moments and dead at others, but never gone, never erased. The block does not release the past, it holds it. It holds everything. Einstein wrote that letter and then died 4 weeks later, on April 18th, 1955. If the block universe is real, then he is still writing it. The ink is still drying on the page. The grief is still fresh, and the physics is still precise, and the sentences are still being formed by a hand that already knows what the equations say about the hand that is forming them. And Godel is still walking with him through the streets of Princeton, still arguing about whether time exists, in a universe that answered the question before either of them was born, still asking astronomers whether the universe is rotating yet, still starving in a hospital bed in 1978. Both of those moments, the walk and the starvation, equally real, equally permanent, equally now. And Minkowski is still standing in that lecture hall in Cologne in September of 1908, still pronouncing his sentence on time, still declaring that space and time are doomed to fade away into mere shadows, still 4 months from death by a ruptured appendix, in an age before antibiotics. According to one account, his last words were a lament about dying just as Relativity was being born. The man who saw the shape of eternity could not buy himself another year inside it, but he did not need to. He was already inside all of it. He always had been. Every moment of his 44 years, from childhood in Alexotas to the lecture hall in Cologne, existing at its coordinates, permanent, real, simultaneous with the death that he could not prevent and the legacy that he could not foresee. And you are still wherever you were 5 minutes ago, and 5 years ago, and at the worst moments of your life, and at the best, you are still in all of those places. You will always be in all of those places. Not because time is a circle, or because history repeats, or because some mystical force preserves the past, because time as you understand it, as a thing that moves and carries you with it, does not exist. What exists is a structure, and you are woven into it. Every version of you, every moment of joy, and every moment of pain, every breath and every silence, every morning you woke up, and every night you did not want to, all of it, permanent, simultaneous, inescapable. The calculations have been checked. The experiments have been run. The equations have been written. And they all say the same thing. The block does not care which moment you think you are in. It does not distinguish your present from your past. It has no flow. It has no clock. It has no mercy. It simply is. And you are inside it. You have always been inside it. Every version of you, at every moment, fixed at its coordinates like a fly in amber, experiencing its slice of the block, and calling that experience now. And nobody told you.